Hello, Lakesy students. So today we're going to look at factoring, the review. You're going to have pen or pencil, the note foldable we made in class, calculator, and then also your thinking cap today. Your learning goals. I can use greatest common factor to factor an expression. If possible, I can factor a polynomial using the grouping method when 4 terms are present. I can factor a trinomial using AC method if possible, and then I can factor a binomial using difference of squares if applicable. So here's that really cool foldable we made in class today. So open your first tab to factor. What does it mean? So you're going to basically open that top flap. Well, basically, to factor means to find out what is originally multiplied to create the expression. Basically, what you're doing is you're undoing the multiplication process. So that's what it means to factor. Basically, it's dividing away something. So the very first thing we're going to look at is greatest common factor. So you're going to want to open up your next flap. Basically, greatest common factor is the question we're going to ask us: what is the largest number of numbers and variables that can be divided out of each term in the expression? So that's the question we're going to ask ourselves. So let's look at this first problem here. I have 6x squared minus 12x plus 18. And I need to be able to figure out what am I going to divide out. So let's first look at these numbers. I have 6, negative 12, and 18. Well, what number can come out of 6, negative 12, and 18? Basically, what number can I divide out? Well, I can divide a 6 out of each of them, right? Now, let's look. This guy has 2 x's, this guy has 1 x, and this guy has no x's. So the question I ask myself, how many x's can I take out of every single one of them? So if I take out 1 x out of every single one of them, each of them has to have 1 x that they can give. Well, this 18 has no x's to give, so I can't take out any x's out of this equation or this expression. So what I'm going to only do is divide out 6. So I'm going to divide this by 6, this by 6, and that by 6. So this is going to be 1x squared. Negative 12 divided by 6 is negative 2x. And 18 divided by 6 is 3. So I have factored out my greatest common factor, which was 6. Let's look at this second example. So on this one, I have 14x to the 4th minus 7x. So for our first thing, what is the largest number I can take out? I know both these are divisible by 7. So I know I'm going to have a 7 outside the parentheses. But what can I take any x's out? Well, this guy has 4 x's, and this guy has 1 x. So how many x's do each of them have to give? Well, each of them can both give an x, right? Only 1 x. So I want to put 1 x on the outside here. This is where it gets a little tricky. So 14 divided by 7 is 2. Now, this, I took out 1 x, right? And I had 4 x's originally. So if I yank 1 x from those 4 x's, I have 3 x's left behind, or x to the 3rd. Now, this one, 7 divided by 7 is 1, and then I already took that 1 x out, so I'm left with no x's. So I'm not going to actually have an x in there. Now, make sure, let's remultiply. I'm going to get 14x to the 4th minus 7x. So I get the original once I multiply it back in, which should always happen. Now, exercise 3 here. So what can come out at 28, 16, and 8? I think it's just a 4. Okay. How many x's? Well, I have 2 x's here, 5 x's here, 1 x here. So the lowest number, or the biggest number of x's I can take out or divide away from every single one of them is 1x, right? Because this guy only has 1 x. What about my y's? I have 1 y here, 1 y there, and 2 y's there. So each of them can only give 1 y. So what am I going to have left? Well, 28 divided by 4 is 7. I had 2 x's originally. I divided away an x, so I have only 1 x left behind. I only had 1 y. Divided him away. He's gone. So he's just sitting out here. He got out of jail, if you want to think of it that way. What about 16 divided by 4? Well, that's going to be left me with 4. I had 5 x's originally, took 1 away, so now I'm at x to the 4th. I had 1 y originally, I took that y away, put him outside, so I have no y's left over. 8 divided by 4, I'm going to be left with a 2. I had 1 x originally, I took him away, so I don't have any x's with this 2, but I did have 2 y's, and I took a y away, so I have 1 y left behind. That is greatest common factor. What about factor by grouping? You may have seen this a little differently than what I'm going to show you. You may have seen it with parentheses. Here's a way to actually organize it just a little nicer. How to factor by grouping. Basically what we're going to use is 4 squares to organize the terms and then factor out GCFs. So basically what you're going to want to do to start each of these problems is you're going to want to put yourself in a box. Like this. Kind of like a window. Now, what's cool is these terms can go in any single box you want. I go left to right and then up and down. Like this. Okay? Now what's really cool is we're going to be able to organize our factors around the edge. So, what two numbers, or what is my GCF of this column right here? Well, I know I don't have any numbers that's GCF, right? But I do have an X. So what I'll do is I'm going to put that X that's a GCF outside of that column. Now let's look at this row. What is the GCF of this row? Well, I know 2 and 4 have a common factor of 2, and then I have 2 x's that these guys have in common. So I get to put 2x squared out there. Let's continue. What do 4x squared and 2 have in common? Well, they don't have any x's in common. However, they do have a 2. So I'm going to put a 2 out there. Let's look here. What do x and 2 have in common? Absolutely nothing, right? But technically, they do have a 1 in common. Here's another way to make sure I know that. What you can do is you can multiply each side to get the inside. So 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared. X times 1 is 1x, and 1 times 2 is 2. So I can make sure that it all kind of worked out. Then what you get to do is write the outsides into your parentheses. I have now factored my polynomial. Let's go ahead and try it again. So, whoa, that was a little crooked of a box. That's okay though. Got fill my box in, 2x cubed, 12x squared. Make sure you take that negative with you. I find a lot of students forget that negative. GCF of this row is 2x squared. GCF of this column, numbers isn't in common, but there is an x. GCF of this column, I think it's a 6. Yeah, it's a 6. And then GCF of this column, looks like it's -5. We can take a -5 out of that. Let's double check our multiplication. 2x squared times x is 2x cubed. 2x squared times 6 is 12x squared. -5 times x is -5x, and -5 times 6 is -30. So let's write our new factors out. X plus 6 and 2x squared minus 5. Perfect. Done with factor by grouping. Let's look at the AC method of factoring. So basically what you're going to do is you're going to take A times C to get started. So A is the first number right with the x squared, and C is the non-x term. Then you're going to ask yourself, what multiplies to make that number and adds to make the middle term? Turn it into a 4-term grouping problem. So let's look on this one. I have a 1 here. It's not there, but technically we know it's there. So I'm going to take A times C. So 1 times -16. So -16. Now I get to think to myself, what numbers multiply to give me -16? So 1 and -16, -1 and 16, 2 and -8, -2 and a +8, -4 and a +4, right? Now, which one of these add to give me this negative 6 that I'm looking for? Well, this is negative 15 if I add together. This is 15. This is negative 6. This is positive 6. And this is 0. I'm looking for a negative 6 when I add. So, ding, 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 found my answer. 2 and negative 8. So what I get to now do is I get to rewrite this, the middle term, as these two factors. Right? Now we can use the handy dandy box that we found. Some of you might be able to do this one in your head, and that's okay. I'm just going to use the box. So, common factor, I get an x, common factor x, common factor of 2, common factor of negative 8. So, my factors, x plus 2, x minus 8. You can multiply this out using FOIL to get this back up right here. Sometimes it's a good check to make sure you did it right. Let's do the same thing here. So I got to go a times c. So 3 times negative 2. Well, that's negative 6. So now let's think here. Numbers that make that. Negative 6 and positive 1. Negative 3 and a positive 2. Negative 2 and a positive 3. One of those has to give me a positive 1x. Right here. Negative 2 and 3, right? Negative 2 plus 3, that's a positive 1. So let's rewrite this. I get 3x squared minus 2x plus 3x minus 2. Box that. Oof, that box went a little wonky, but that's okay. 2x, 3x, negative 2. Common factor here, you get 3x. Looks like just an x these guys share. These guys share a negative 2. And then these share absolutely nothing, but they do share a 1. So I got my factors of x plus 1 and 3x minus 2. And I have factored my trinomial. Trinomial means you have 3 terms, just in case you were unsure of what that meant. And the last kind, difference of perfect squares. Basically, you need to make sure that you have some criteria before you even try this. So you need to identify if you have a difference. So you have subtraction in the middle. Then you need to make sure, do you have 2 perfect squares? Are both of the numbers with a squared in them? And then you're going to use it to factor into 2 factors. What this is going to normally look like. One is going to be one with a plus in the middle, and one's going to be one with a minus in the middle. So, let's double check. I have subtraction. Pass the first test. Number 2, do I have perfect squares? Well, this is perfect square, right? X squared. And 16 is a perfect square of 4. So what I can do is I can break this into x plus and x minus. Okay? Because there's technically a 1 there. Now, I need to break this square root of 16 into my two squares, whatever multiplies by each other. So 4 and 4. I'm done. I have factored that out. Here's how I know it's a plus and a minus. I need 0 in the middle here, right? So if I get negative 4x plus 4x, I get a positive 0. So that allows me to know that I need one negative and one positive, and it needs to be the same number. Let's try this one. So let's check. Do we have subtraction? Yep. Do we have a perfect square? We do. So what I now get to do is I need to break this apart into my 2. One's going to have a plus, one's going to have a minus. Now notice, this one had a number in front. So what we do have to do is take the square root. So square root of 4 is 2x. So I get 4x squared is technically 2x times 2x. Same thing, square root of 9, 3 and 3. Not too bad, right? It's kind of like a pattern. Let's double check here. We got subtraction, 2 perfect squares, we're golden. So I got a plus, I got a minus. 16x squared. Well, we know that's 4x and 4x, right? Because we got to square root both of those. Square root that 25, we get a 5 and a 5. Done with there. Let's do this one. I got subtraction. First one's done. 2 perfect squares. Well, 4x squared, that's perfect square, but don't think 7's a perfect square. So this one is not factorable. Womp womp. So we'll have to find out a new way to be able to factor that or solve for that problem. And that's the end of this video. See you later, Sabers.